Come in, Orson. Mork calling Orson. Come in, Orson. Mork calling Orson. Come in, Orson.
And twiddle my incoming message from the big giant head.
Excise the big giant head!
Professor Berendzen teaches a course entitled Search for Life in the Universe.
It's that the number of stars in our galaxy alone is so staggeringly large, of the order of 10 to the 11 or more. The probability of stars having planetary systems is so high, we think perhaps half. The probability that those planetary systems might be comparable with our own, and that the stars have some kind of an ecosphere, a sphere in which the radiation is suitable for life, that it's not too hot, not too cold, meeting the other criteria, seems so reasonable. These bits of information have come from astronomy primarily. And then we join with the biochemists who tell us about the probable evolution of life here on Earth, the kinds of elements that are necessary for it, DNA molecules, amino acids and the like. Amino acids which have now been found in meteorites, that we have now found interstellar molecules floating out in the space between stars. So that you know the materials for a carbon-based life exist. We know that many of the building blocks of life in our own solar system exist off of our planet. If you put these kinds of probabilities together, it begins to lead to the sorts of conclusions that we started with as an initial premise, and which apparently no one on the panel has disagreed. And that is that life must exist in the universe, and it must exist quite abundantly.
And finally, it would end our social and cultural isolation. To date, we have been bounded not only into our own countries and into our own small regions on this planet, but most assuredly within our solar system itself. If there are the tens of billions of other civilizations which the predictions indicate might be, then we would join a larger galactic community.